Hello and welcome. In this video, we're going to talk about the key characteristics that can help us create a graph or a model. We're then going to use those characteristics to sketch a graph. So our goal in this lesson is that we can identify the key characteristics of a function such as symmetry and intercepts, and that we can use them to graph. So let's go ahead and jump right in. So the first thing we're going to talk about, an easy way to find points right away that are significant and helpful points when we're creating a graph, is to find the intercepts. And as we have learned in previous classes, we can find the y-intercept by plugging in 0 for x. We can find the x-intercepts by setting the function or the y value equal to 0 and solving for our x. And once we know those intercepts, we immediately have a handful of points that we can plot, which will create our graph or give our graph a starting shape. So let's focus on how to find those intercepts. Since we're graphing, we also want to make sure that we're writing those intercepts as coordinates. So to find the y-intercept, we're going to find out what happens when we plug 0 into our function. And in this case, that's going to give us 0. So our y-intercept is going to be 0, 0. To find the x-intercept, we're going to set the function equal to 0. This is going to allow us to solve by factoring. And this is going to give us 0 and plus or minus 2. And we can write those as coordinates, again, because ultimately we're going to be using these points to graph. Let's go ahead and look at a couple more examples of finding intercepts. Now I'm going to encourage you to pause the video and find these intercepts on your own, and then unpause the video and see how you did. So first thing, for both numbers 1 and 2, I'm going to go ahead and plug in 0 to find the y-intercept. So if we plug in 0 for x, we can find the y values that make our statements true, and then I'm going to go ahead and find the x-intercepts by plugging in 0 for y in number 2, and by setting g of x equal to 0 for number 1. And there we have it. So intercepts will give us at least a couple of points, sometimes just one, that will help when we're starting to sketch the shape of our graph. Now let's see if we can explore or review something else that will help us start creating our graphs. So the second helpful characteristic we're going to briefly recap in this video is using symmetry. So if we know that a function is symmetric about either the x-axis, the y-axis, or the origin, it actually means every time we find one point, we can use that symmetry to find a second point. And that's going to make our lives easier when we graph as well. So just as a reminder, in order to determine if a function is symmetric about the y-axis or an even function, what we do is we plug negative x in for x. And if we end up getting the exact same function, then we can say that our function is symmetric about the y-axis or it's even. If we run that same test plugging in negative x for x, but we get the exact opposite function, then we have a function that is odd, which is symmetric about the origin, as if you rotated it 180 degrees. Lastly, some functions such as horizontal parabolas and occasionally circles could have symmetry about the x-axis. To test for this, we're going to swap y with negative y. We're going to plug that in, and if we get the exact same function, then we have a function that is symmetric about the x-axis. So let's go ahead and look at a couple of examples and determine the symmetry for each of our functions. So you may not need 3 examples here, but what I'm going to encourage you to do is to pick at least 2 of them. And first, go ahead and plug in negative x for x. So substitute every x with negative x and simplify and decide whether you get the exact same function, the exact opposite function, or neither. Then unpause the video and see how you did. So hopefully you gave yourself some time to do that. On number 5, we end up with the exact same function, x squared minus x to the 4th. That means that number 5 is even and it has symmetry about the y-axis. On number 6, we end up with the exact opposite function, which means number 6, this cubic function is odd and it has symmetry about the origin. Number 7, we also get the exact same function, which means it is even and symmetric about the y-axis. Now, the only other thing we need to test for is potentially symmetry in the x-axis, which would mean we would let y equal negative y, and we're looking to see if everything is exactly the same here. That's not true. So the only symmetry that exists on number 5 is going to be for the y-axis. The same thing, I think you can probably already see this. This is not going to be exactly the same. So the only symmetry on number 6 that is true is the origin. Number 7, if we plug in negative y, we're going to end up squaring that. So we're going to end up with exactly the same function. So this function also has symmetry about the x-axis. So x-axis and y-axis symmetry, which makes sense because number 7 is a circle. So now that we've spent some time talking about how do we find intercepts and how do we find symmetry, let's tie this together and how do those things help us create a graph? Okay, so here we have a function that looks very similar to the functions that we just looked at. So we're going to start by finding those key characteristics and using them to graph. And then we may need to make a table to find another point or two to help us really be able to sketch out that graph well. So what I want you to do is go ahead and pause the video, find the x and y intercepts, and determine any symmetry. Then unpause the video and see how you did. So here we have the y-intercept, the x-intercepts, and that this function is odd and symmetric about the origin. So let's go ahead and plot those intercepts. And I'm going to go ahead and adjust the scale just so that you can see the points separated out a little bit better. So in order to connect these, we probably want to plug in 1/2, which we know we can do the exact opposite to find a second point. So let's plug in 1/2 and let's plug in 2 so that we can get a couple more points on our graph. All right, so here we have a couple more points. Now remember, since our function is odd, if we have the point 2, 6, we also have the point -2, -6. If we have the point 1/2, -3/8, we also have the point -1/2, +3/8. So let's go ahead and plot those points. All right, so because I adjusted the scale, those 2, 6, and -2, -6 don't actually fit. But that really helps me I can approximate where that's going to be. So then I'm going to go ahead and connect the dots. It's going to make like a sort of swoop shape here. And there we have our graph. So if you feel confident in this, you can go ahead and start working on the practice problems. If you'd like to see a couple more problems graphed, we're going to quickly jump into some more examples and then wrap up this video. All right, so here are 3 more great practice problems, and you may be able to use some things that you already know, like number 8 is a quadratic and it's in vertex form. That might help you. Number 10 is just a slight translation from the parent function for a cube root. Number 9 is a little tricky, but it is a parent function. So I encourage you to pause the video and take what we learned in this section and apply it to these 3 problems. And I will go ahead and work through them as well, and then you can see how you did. Now, we're all coming in with different levels of strengths from previous courses, so you may have needed to do this much work, you may not have, and don't worry, we're going to practice with all these types of functions as well. So let's do a quick recap of what we covered in this video. All right, so our goal was that we could identify key characteristics such as symmetry and intercepts, and then use them to start sketching graphs. We talked about how to do both of those things, and we tied them together with a quick example on graphing, which we're going to spend more time practicing together. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.